Can cast aluminum pistons really be used? The answer lies in a small workshop in Pakistan. They melt discarded aluminum alloy parts. And with just basic lathe processing, they create beautifully crafted engine pistons. Because imported brand-name pistons are expensive, this open-air workshop has set up a production line specifically to make high-cost performance pistons for their trucks. Before casting begins, the technicians select scrap aluminum alloy parts. Once the furnace reaches the appropriate temperature, they melt the alloy, using heavy oil for heating at the bottom. They continuously add more scrap pistons to the furnace to maintain the flow of raw material. Once the aluminum melts fully, the technicians skim off any impurities, leaving only pure aluminum in the furnace. Because sand mold casting is difficult and prone to defects, the workshop has customized an iron mold for this process. Although iron molds can't match the quantity of sand molds, they are much faster to work with. After pouring the molten aluminum into the mold, it is stirred with iron rods to ensure it fills every corner. No cooling period is required before removing the mold, which is sprayed with a release agent and coated with talc powder for easier separation. These cast pistons come out smoother and more even than those made by sand casting. Taking only 10 minutes to produce a batch, the finish is far superior to sand cast pistons. Additionally, any excess aluminum from the mold spout is cut away, and these aluminum scraps are collected as pure, reusable raw material. After remelting, the aluminum can be reused for casting. Once the cutting is complete, the piston is fixed on the lathe chuck. Before machining the piston pin, it is essential to ensure the piston is concentric. Once this is done, a cutting tool is used to smooth the top of the piston. This process does not compromise the piston's precision. During the design phase of the casting mold, the machining considerations are already factored in, so the piston shape may not match the original factory design. The external diameter of the piston is larger, and the inner diameter is slightly smaller, allowing for a margin of error. This gives the technician 2 chances to correct any mistakes. After surface finishing, a slot cutter is used to cut the grooves for the piston rings. The technician knows the specifications for the 3-ring grooves by heart and can make the necessary adjustments with slight movements of the cutting tool. At this stage, the casting has become a semi-finished product, and it must be smooth to the touch to be considered acceptable. Since the piston hole is slightly smaller than required, the technician not only smooths the inner wall but also enlarges the hole until it matches the pin dimensions. Once the hole is complete, a drill press is used to create a perfectly centered hole, which is essential for the piston pin. These return holes are crucial for the piston's function as they allow the piston rings to scrape excess oil from the cylinder wall, facilitating necessary lubrication and movement. This final step completes the machining of the piston cast in an iron mold. In Pakistan, such pistons are definitely usable and reliable.